Symmetry. Symmetry about the line x is equal with h. The graph of a polynomial function y is equal with f of x is symmetric about the line x is equal with h if f of p plus h is equal with f of p minus h for every number p. For f of x is equal to x squared plus bx plus c, a different from 0, set f of h plus p is equal with f of h minus p, and show h is equal with minus b over 2a. So first of all, here, instead of in the terms of the x here, what is this quadratic function, we are going to work in terms of the h plus p and h minus p. But I'm going to use this equation here, to work with this equation. And now let me go with the left side. And here is a, and instead of the x squared, I'm plugging here h plus p, which is a square. And then we have a plus b here, the coefficient b, I will write coefficient b here. And instead of the x, I'm plugging here h plus p. And I have a plus c. C is a constant, so I am not making any further change here. So now I'm going to the right side. Let me write this with a different color. And here I'm using a, but I am working here in terms of the h minus p in the left side. And whenever I have x, I am plugging here in h minus p. But because it's x squared, h minus p is a square. And the coefficient plus b is there. So I will write a b. And instead of the x, I'm plugging in h minus p. And now plus c. But we see this equation here, what we have. In this equation, c is in both sides. So whole equation I am going to subtract by c. I am subtracting here by c. And c's are going to cancel. So this is going to cancel. So I have less work. So I'm trying to make as less work as possible. I'm going to simplify. So now here h plus p squared, I can expand this. And this I'm going to take a shortcut. I can write h squared plus 2hp or 2ph. Doesn't matter in which way we write, because commutative multiplication is commutative, and it works. It has a commutative property. So now plus b squared. And then here I'm going to distribute b times h plus b times p. Oh, let me distribute this. B times h plus b times p. So here we have. And in the other side, I'm going to do the same steps. And a is in the front here. And I'm going to expand this formula. X minus p times x minus p, h minus p times h minus p is going to give me this result here. So I'm going to take a little bit of shortcut, 2ph, so I'm writing the same way as the other side, and plus p squared. And in the other side, I am going here to distribute b in h minus p, and it's going to be plus bh and minus bp. And now I'm looking here, do I have anything similar, so I can subtract both sides immediately, and I can take away. And here I see bh. I have here bh, and in the other side is bh. So those two terms I'm going to cancel, and let's see then what's going to happen. This I'm canceling because the same term with a different same items with a different sign, so they can be cancelled. And here now I'm going to distribute everything inside parentheses, And if I'm distributing everything, it's going to be a h squared plus 2a ph and plus ap squared. Just let me make this better because look, okay, plus bp. So I have all the factors, I didn't, all the terms, I didn't miss anything. And same thing, I'm going in the other side, I'm going to distribute a inside the parentheses, and ah squared minus 2a ph. So okay, I'm going same way, I will write, plus ap squared. And what do I have here in the other side? I have a minus bp. So just let me write correctly. And I'm looking, what do I have here? The same. Minus a h squared is same. So I am subtracting whole equation by a h squared. Same thing I'm going here. Minus a h squared. I'm going to subtract both sides. Then what do I have else? Plus 2ap. This is not. Plus ap squared. It looks the same both sides. So let me take this away. And the equation will have less terms and much easier to manipulate them. And now we have ap squared. And now whatever we have are the same factors with different signs, I'm going to cancel. So those are going to cancel everything. So we left with very few things, with very few terms. 2ap, h, and I have a plus bp, and in the other side we have a minus 2aph. Let me write the different colors. So minus 2 aph. Okay, aph, and I have minus bp, bp. And now I'm looking here, what do I have here to do it? So I have a plus a bp. So what I'm doing here, I'm going both sides, I'm going to work with minus bp this side, and minus bp here, pb. Okay, bp pb is not big problem, so I don't want to rewrite again. But this one I want to put in the other side, so I'm going to work with a plus 2aph, and in the other side again I have plus 2aph. So both sides I have the same term. Now what I'm going to do here, this is going to cancel here, and this here is going to cancel, and what remains here, now I'm going to write with the same color. 2aph plus 2aph is a 4aph, and this is equal with a negative bp. Negative bp is negative 2bp. But because I have here the same p, I'm going this to divide by p everything. And when I divide by p, I divide this side by p, and I divide this side by p. So it turns out p is going to simplify, and this p is going to simplify, and what remains here remains 4ah is a 4ah, and is equal to minus 2b, So everything now I divide by 4a, and now if I divide everything by 4a, h is going to be equal with a minus 2b over 4h. But I simplify 2 by, if I divide everything by 2 upper side and lower side, finally h is going to be equal, so this is finally h is going to be equal with a minus b over 2a. So we already proved it. But if we are looking this here at this situation, it says x is equal with h. So axis of symmetry we already know. X is equal with minus b over 2a. So we already proved this formula 2a. We already proved the axis of symmetry, and I think it's done the proof. So just let me frame this final result.